Hello everyone. I am Asit Dwivedi, Assistant Professor, IIMT College of Management. Today, today I will take session on computer architecture and assembly language. Computer architecture and assembly language. First, we will discuss architecture of the computer, and then we will discuss about assembly language. So, computer system architecture. A computer system is basically a machine that simplifies complicated tasks. It should maximize performance and reduce costs as well as power consumption. The different components in the computer system architecture are input unit, output unit, storage unit, arithmetic logic unit, and control unit. This is the diagram that shows flow of data between these units is as follows. This one is input unit. Input unit input unit takes data from outside world in human acceptable form. Input unit takes data from outside world in human acceptable form. Okay, then input unit will transfer that data to storage unit, arithmetic logic unit, control unit. Okay, so arithmetic logic and control unit together is called CPU. Okay, after processing data from arithmetic logic unit, this will give data to output unit. Output unit, output unit will take data in machine language, and output unit will convert that data into human acceptable form. The input data travels from input unit to ALU. Similarly, the computed data travels from ALU to output unit. The data constantly moves from storage unit to ALU and back again. This is because stored data is computed on before being stored again. The control unit controls all the other units as well as their data. Input unit. Now I will discuss input unit. The input unit provides data to the computer system from the outside world. So basically, it links the external environment with the computer. It takes data from the input devices, converts it into machine language, and then loads it into the computer system. Keyboard, mouse, etc. are most commonly used input devices. Now, output unit. The output unit provides the result of computer process to the user. That is, it links the computer with the external environment. Most of the output data is the form of audio or video. The different output devices are monitors, printers, speakers, headphone, etc. Storage unit. Storage unit contains many computer components that are used to store data. It is traditionally divided into primary storage and secondary storage. Primary storage is also known as main memory. Main memory and is the memory directly accessible by the CPU. CPU can directly access the main memory. Okay, there is direct interaction between CPU and main memory. Okay, now secondary or external storage is not directly accessible by the CPU. Secondary memory is not directly accessible by the CPU. The data from secondary storage needs to be brought into primary storage before the CPU can use it. Okay, so for CPU, data will come from secondary memory to primary memory, and CPU can access data from primary memory. CPU cannot interact directly with secondary memory. Secondary memory, secondary storage contains a large amount of data permanently. Now, next is arithmetic logic unit. All the calculations related to the computer system are performed by arithmetic logic unit. It can perform operations like addition, subtraction, multiplication, division, etc. The control signal, sorry, the control unit transfers data from storage unit to arithmetic logic unit when calculations need to be performed. The arithmetic logic unit and the control unit together form the central processing unit. Now, next is control unit. This unit controls all the other units of the computer system and so is known as its central nervous system. It transfers data throughout the computer as required, including from storage unit to central processing unit and vice versa. The control unit also dictates how the memory input-output devices, arithmetic logic unit, etc. should behave. Now, I will discuss concept of hardware and software. What is hardware? Hardware, what we can touch in computer, that is called hardware. Physical components of computer. The term the term hardware refers to mechanical device that make up computer. Computer hardware consists of interconnected electronic devices that we can use to control computer's operation, input and output. Examples of hardware are CPU, keyboard, mouse, hard disk, etc. See, this is the photo of the hardware. See, first one, there is casing. Casing means cabinet of the CPU. Then there is CD DVD drive. Okay. Then hard disk drive. Okay. Then motherboard. Then sound card. Then video card. Then RAM. Then power supply. This is the power supply. Okay, this one is SMPS. SMPS stands for switch mode power supply. This is the This is the SMPS. SMPS that supplies different voltage to different parts. SMPS is known as switch mode power supply. Now, hardware components. Computer hardware is a collection of several components working together. Some parts are essential and others are added advantages. Computer hardware is made up of CPU and peripherals as shown in image below. See, this is the central part where CPU is located. And in input devices, first one there is keyboard, mouse, and other input devices. These input devices will transfer data to CPU, and CPU will process that data, and this will give process data to output devices like monitor, printer, speaker, or other output devices. Software, a set of instructions that drives computer to do stipulated tasks is called a program. Software instructions are programmed in a computer language, translated into machine language, and executed by computer. Software can be categorized into two types. First one, there is system software. Next one is application software. Now, system software. System software operates directly on hardware devices of computer. It provides a platform to run an application. It provides and supports user functionality. Examples of system software include operating systems such as Windows, Linux, Unix, etc. Now, next is application software. An application software is designed for benefit of users to perform one or more tasks. Examples of application software include Microsoft Word, Excel, PowerPoint, Oracle, etc. Now, I will discuss one more topic, system bus. System bus in computer architecture. Now, let us see what is the system bus. What is a system bus? A bus is a bus is a set of electrical wires that connects the various hardware components of a computer system. It works as communication pathway through which information flows from one hardware component to the other hardware component. A bus that connects major components, CPU, memory, and I/O devices of a computer system is called a system bus. And this is the diagram of system bus. See here, CPU is connected to system bus, memory is connected to system bus, and these are the I/O input output devices. These are connected to system bus. Why do we need bus? A computer system is made of different components such as memory, ALU, registers, etc. Each component should be able to communicate with other for proper execution of instructions and information flow. If we try to implement a mesh topology among different components, it would be really expensive. So we use a common component to connect each necessary component, that is bus. Now, components of a system bus. The bus consists of three major components. First one, that there is data bus. This one. Second one, address bus and control bus. Okay. Data bus, address bus, control bus. There are three types of buses: data bus, control bus, data bus, address bus, control bus. See, this is the diagram of system bus. First one, data bus. As the name suggests, data bus is used for transmitting the data instruction from CPU to memory IO and vice versa. It is bidirectional. The width of data bus refers to the number of bits that the bus can carry at a time. Each time, line carries one bit at a time, so the number of lines in the data bus determine how many bits can be transferred parallelly. The width of data bus is an important parameter because it determines how much data can be transferred at one time. The wider the bus width, faster would be the data flow on the data bus, and thus better would be the system performance. Examples: a 32-bit bus has 32 wires, thus can transfer 32 bits of data at a time. A, a 64-bit bus has 64 wires and thus can transmit 64 bits of data at a time. Control bus. As the name suggests, control bus is used to transfer the control and timing signals from one component to the other component. The CPU uses control bus to communicate with the devices that are connected to the computer system. The CPU transmits different types of control signals to the system components. It is bidirectional. What are control timing signals? Control signals are generated in control unit of CPU. Timing signals are used to synchronize the memory and IO operations with the CPU clock. Now, address bus. As the name suggests, address bus is used to carry address from CPU to memory IO devices. It is used to identify the particular location in memory. It carries the source or destination address of data, that is, where to store and from where to retrieve the data. This one is unidirectional. Example: when CPU wants to read or write data, it sends the memory read or write control signal on the control bus to perform the memory read or write operation from the main memory, and the address of the memory location is sent on address bus. Address bus width. The width of address bus determines the amount of physical memory addressable by the processor. In other words, it determines the size of the memory that the computer can use. The wider is the address bus, the more memory a computer will be able to use. The addressing capacity of the system can be increased by adding more address lines. Examples: an address bus that consists of 16 wires can convey to the power 16 equal to 64K different addresses. An address bus that consists of 32 wires can convey to the power 32 equal to 4G different addresses. Now, computer register. Registers are a type of computer memory used to quickly accept, store, and transfer data and instructions that are being used immediately by the CPU. The registers used by the CPU are often termed as processor registers. A processor register may hold an instruction, a storage device, a storage address, or any data. The computer needs processor registers for manipulating data and a register for holding a memory address. The register holding the memory location is used to calculate the address of the next instruction after the execution of current instruction is completed. Now, this is the list of registers. First one, there is data register, then address register, then accumulator, instruction register, program counter, temporary register, input register, and output register. And these are the symbols for different registers: data register DR, address register AR, accumulator AC, instruction register IR, program counter PC, temporary register TR, input register INPR, and output register OUTR. And these are the number of bits of registers. Now, computer languages. There are three types of languages in computer. First one, there is hardware, then machine language, then assembly language, then high-level language. High-level languages are Java, C++, Pascal, etc. And hardware, machine language directly interacts with hardware. Assembly language and high-level language, these are not interacts with hardware directly. Machine language is easier for computer to understand, but harder for the programmer to understand. This is because machine language is simply the language of machines' bits. Sometimes programmers will develop programs directly with machine code, but because this is difficult to understand and tedious to type, it is a more common language. It is more common to program using assembly or high-level language. Now, what is assembly language? Each computer has a microprocessor that manages the computer's arithmetical, logical, and control activities. Each family of processors has its own set of instructions for handling various operations, such as getting input from keyboard, display information on screen, and performing various other jobs. These set of instructions are called machine language instructions. A processor understands only machine language instructions, which are strings of ones and zeros. However, machine language is too obscure and complex for using in software development. So the low-level assembly language is designed for a specific family of processors that represent various instructions in symbolic code and a more understandable form. Now, assembler. The assembler is used to transfer the program written in assembly language into machine language. Assembler converts assembly language program into machine language in the form of zeros and ones. The source program is an output of an assembler that contains assembly language instructions. The output generated by the assembler is the object code or machine code understandable by computer. Assembler is basically the first interface that is able to communicate humans with machines. We need an assembler to fill the gap between humans and machine so that they can communicate with each other.